Hello and welcome back. So uh, about maybe a day ago, a little more than a day ago, we conducted our first static fire of this rocket, which is the first ever booster ever developed for a Kolit 0.1. There was some engine issues with the engine about halfway into static fire that eventually led to a forced shutdown of the engine. So we will be trying again after some maintenance. We will be conducting two back-to-back static fires. And what I mean by back-to-back is we will light the engine, turn it off, wait a little bit, and then turn it back on just to see, and then turn it off, drain all the fuel. That's basically what we're going to be doing. Uh, it'll test a relight along with engine reliability, things like that. So do not expect this to survive. We've taken the precautions. Uh, we've loaded the rocket purposefully with smaller amounts of fuel this time around and just simply increased the clamp, the amount of pressure the clamps have on the rocket, just to make sure it's bolted down to the ground as much as possible. So that pressure is very important. Currently, the pressure is fairly low, but in those last couple moments before the static fires, they will be upped quite a bit to ensure that the rocket is kept down. Those small struts that you see, those don't hold the rocket that much. They just make sure it doesn't wobble as much. So it's very important with those clamps. The rocket has already been fueled, just waiting for some last little checks. Clamps are looking good. One of the things we're going to be testing in this double static fire will actually be the clamps, as they are very important to ensuring a safe testing environment for future tests that may be longer duration than these current tests. Possible testing of entire launch sequences, such as first stage and second stage burns. And of course, relights. Eventually, we may plan to, have boosters do multiple burns to ensure they can deliver the second stage to the proper area, but not have to worry about coming down on populated areas by conducting a other burn to divert them to an uninhabited area, such as the ocean or desert or such area. So this is our launch site in Marty, Texas, and the site is already been filled with many test prototypes. If we look around, you can see this view of the engine, this other view of the engine from a different standpoint. You can actually see over here the other camera, its location right there. And if we switch over to this feed, you can see both cameras. There's one there and one there. Both of those cameras essentially will do some work for ensuring that we can see the engine at all times. So now, as you can see, this little pipeline is actually what feeds the fuel into the rocket stack. And if we look below, you can see this, which is a flame deflector. This specific area is the water-cooled steel plate. Pipes run through here that are filled with water to ensure that the exhaust is cooled down enough to where the concrete below there does not get too hot and possibly liquefy or crack significantly, because that could hinder our quick cadence with these rockets in the future. So I'll be switching back to this cam. It's simply known as fuel line cam, as it's located towards the end of the fuel line. And this is where we previously saw that issue. It's around sunset time. We're hoping to get this test completed by the end of sunset, and the test is set to be completed very soon, likely within the next minute. Currently conducting go, no-go poll. So just waiting to hear in from them. And yep. We are go for static fire. So, yeah, that means we're going to be switching over to a better camera, such as this one and this one. So we'll just switch between these two if we want to. And we also have this one too. We'll stick between these two, I think, is what we're settled on. Okay, we're going to have the engine power up right now. And ignition. And we'll see that run for a little bit. Followed by a shutdown. You can see the engine is actually now glowing towards the end. And we should have a shutdown here very soon. Throttle down and shut down. Alright, it was a successful test. I'll switch cameras here. You can see it's glowing. And you can also see the sunset currently taking place. You see the sun very low on the horizon there. We're hoping we can get this second test done before the sun fully sets, so you can get a good view. So we'll switch back to fueling cam for this next little static fire. We're just waiting according to mission control. The engine is in good condition. Clamps are still fully pressurized. Both forms of clamp, the ones that connect to the upper gantry and the ones that connect to the rocket. Although those struts that hold it so it doesn't jiggle around some of them are apparently a little weird, so they're messing with those. But even if they can't fix those back up, the test can still happen. It might just jiggle a little bit, which is nothing bad. It happens even to the best rockets. So just waiting that. There we go for our second static fire. Should hear that very soon. Alright, and there you go. Okay, so apparently the strut issue was pretty much unavoidable there. There's no way to just automatically re-strengthen it, so we should be hearing, remember the engine has already been started up, so they just need to relight it, which is going to be difficult. Alright, we should see that here in maybe a couple seconds. Alright, there it goes. It's doing good. And, oh, there's some weird stuff going on, apparently. Well, what's... Oh. By the looks of things, they have just experienced a rapid unscheduled disassembly. So currently, all of our cameras are out, and we're waiting to hear any word from the launch pad, but last we saw was that was not a fun sight to see. Looked like the rocket sort of took off and then spun out and fell back down. We also saw what appeared to have been an explosion, possibly multiple explosions. Wow. That was not what I expected. So apparently those struts may have been an issue that we may have to investigate. We'll see. So this is okay. We've got a simple. This is a immediate response. So this is actually a flight profile. This shows these different things. So currently its final recorded speed was 19 meters per second, 0 meters up, and it apparently had 5 seconds of airtime. According to these flight events, there was a liftoff recorded at, of course, 0 seconds. There's a separation, 0 seconds as well, believed to have been automatic triggering of flight termination, which just shuts down the engines. At 5 seconds in, there was some sensors on certain parts of the rocket that reportedly hit the ground. So at 5 seconds, all of these parts, sensors recorded that they had hit the ground. And if we look at these basic things, it lasted 5 seconds. Its highest altitude was 761 meters. Its highest speed was 123 meters. It covered 47 meters, so it went downrange 47 meters. Total distance traveled was 82 meters, and most G-force endured was 3.2 Gs. So these are some basic sensor readings that we've got there. This is directly from the flight computer, almost like a black box. It is very hard to be destroyed, and it immediately sent us this basic data. Now it says 761 meters, but you do realize that ground level is 733, so that averages around 20, 28, 27 meters, somewhere around the lines of that. So yeah, not great. It appeared it took off and then immediately lost control and fell back down to the ground after some explosions and things. So does not look like we're going to be having any more static fires with that vehicle. All of our cameras in the nearby area were sadly destroyed by the looks of things. As you can see, the last view was a shot at the sun. The sun is so bright that it actually blacked out the rest of the video here. So this is pretty much it. So the flight computer reading said this. So just gotta hope we can quickly figure out what the issue was there, or if it had anything to do with the struts, or if it was another issue that happened at the same time. But very unfortunate end to our first booster for the Kolit 0.1. This mock-up was meant to just simply do some engine testing, possibly do a test full stack on the launch pad, but now the second stage is requiring a test, so we will do that likely. In the meanwhile, we'll have to build a brand new booster and test it as well. Hopefully, we'll have some upgrades to launch infrastructure and the engine to make sure that issue that they had on the first static fire won't happen again, and also make sure that whatever issue we just saw there only minutes ago also doesn't happen again. So that's it. We gotta go analyze the footage, and that'll be that. So hopefully we'll see once that second stage is tested with the brand new upgraded upper stage engine. So yeah, we'll see what happens to that engine.